Hi everyone, welcome back to another Algebra 1 tutorial. In this video, we'll be going over the basics of linear functions. So the key concepts for this video is going to be standard form, intercepts, finding intercepts, rate of change, slope, slope formula, and direct variation. So linear functions. So what are linear functions? Well, linear functions are functions that when graphed form a straight line. So graphs with curved lines like parabolas are not examples of linear graphs, suggesting that the function itself is not linear. Identifying linear functions through tables. So suppose we have the following table. We have different x values and y values. So we have 2, 4, 5, 3, 8, 2, and 11, 1. And we're told to find if this is a linear function or not. So the best way to find out if we see a constant change in x and y, then we can conclude that it's a linear function. So if we add 3 to 2, we get 5. If we add 3 to 5, we get 8. And if we add 3 to 8, we get 11. And similarly, we subtract 1 to 4, from 1 from 4 we get 3, 1 from 3 we get 2, and 1 from 1 and 1 from 2 we get 1. So since there is a constant change in both the x values and the y values, we can conclude that this is a linear function. So standard form. So in standard form, a linear function is written like so. So we have ax plus by is equal to c, where a, b, and c are all real numbers, and a and b are not equal to 0. So notice that when a linear equation is written in standard form, x and y both have exponents of 1. X and y are not multiplied with each other, and x and y do not appear in radical signs. Denominators are exponents. So we never see x and y like this, or like this, or in exponents. So let's look at intercepts. So the intercept of a line is the point at which it touches either axis. So the x-intercept is when it touches the x-axis, which is the horizontal axis, and the y-intercept is when it touches the y-axis or the vertical axis. So suppose we have 2 dots. We can say that this one is the y-intercept and this one is the x-intercept. And also remember that any 2 points graphed on a plane can form a line when connected to each other. So using the intercepts themselves, you can graph lines. And we're going to be looking at how to solve intercepts now. So first, let's look at finding intercepts from functions. So suppose we have the following function, 3x minus 2y is equal to 12. So to solve for the x-intercept, we need to substitute y for 0. So 3x minus 2 into 0 is equal to 12. And negative 2 to 0 gives us 0. So it simplifies to 3x is equal to 12. And take out the 3 and you get x is equal to 4. Or the x-intercept is equal to 4. So remember that whenever you find the x-intercept, the y value always equals to 0. And similarly, whenever you're finding the y-intercept, the x value is always equal to 0. Since if you look at it in a graph, suppose you have the y-intercept, you can see that the y goes either up or down, but the x always stays here. And similarly, if you're finding the x-intercept, you can see that the x always goes positive or negative, but the y always stays here. So suppose we would want to find the y-intercept, we would substitute x with 0. So you would get negative 2y is equal to 12 and divide both sides by negative 2 to get y is equal to negative 6. So in coordinate form, you would be writing the y-intercept as 0, negative 6, since x is always equal to 0 in the y-intercept, and similarly you write the x-intercept as 4, 0. Finding intercepts from tables. So now let's look at a table. So you have the following table. So since we know that whenever you want to find the y-intercept, you have to check for the y to be 0, and similarly for the x-intercept, the y has to be 0. So you would say that the y-intercept would be 0, 4500, and the x-intercept would be 15, 0. And if they give us units, suppose this was minutes and this was feet, we would say y-intercept is 4500 feet and the x-intercept is 15 minutes. And suppose they ask the significance of this, so we can say that the 4500 feet gives us the height of that specific object at 0 seconds, so the initial height, and 15 minutes gives us the number of minutes it takes for that object to fall to the ground. And the graph would look something like this. So now let's look at a problem. We have 2x minus 4y is equal to 8, and they want us to find the x and y-intercept. So to find the y-intercept, we need to substitute 0 to x, so we would get 4y or negative 4y is equal to 8 and y is equal to negative 2. Similarly, we would get 2x is equal to 8 and x is equal to 4. And when graphed, this would be a graph, so negative 2y over here and 4x over here, and connect it, and we get a line that actually goes up over time. So it's a line which has a positive rise. And suppose we have another function, 2 over 3y minus is equal to 4 minus 1 by 2x. So to solve this, we could substitute the values like normal. So 0 and 3 by 2 times 2 by 3 cancel out both values. So 3 by 2 times 2 by 3 cancel out, and 3 by 2 times 4, and you get 6. You get the value as y is equal to 3 by 2 times 4, which is 6. And similarly, you will get negative 1 by 2x plus 4 is equal to 0, and negative 1 by 2x is equal to negative 4. So 1 by 2x is equal to 4, and you would multiply 2 to both sides to get x is equal to 8. And these would be our x and y intercepts, so 0, 6 and 8, 0. And the line would look something like this. So it's a downward slope. So what is rate of change? The rate of change is the ratio of the dependent variable over the independent variable. For example, suppose 100 gummy bears are made every second. The rate would be gummy bears over seconds. So 100 gummy bears over every second. So gummy bears over seconds would be our rate. So similar to rate of change, the slope is also changed in two values. However, for this one, it would be the change horizontally and vertically, or the change in y over the change horizontally, or the change in x. So you can also say this is rise over run. So run is horizontal and rise is vertical. So suppose we have something which increases 2 vertically every time it increases 1 horizontally. We would say that it has a slope of 2 over 1 or 2. So there are also special types of slopes. So we have undefined and zero slopes. So lines which are graphed vertically. So suppose we have the y-axis and we have the x-axis. The line which is graphed vertically, this one would have an undefined slope. However, whenever you graph a line horizontally, this would have a zero slope. So for undefined slope functions, you usually will not be able to write a function rule for it. For zero slopes, on the other hand, it would be something like y is equal to. And undefined slopes would be x is equal to. And there's no proper function for either of these. The function can either have y or x, but it can't have both. So either y is equal to, so suppose the value over here is 3, it would be y is equal to 3, and the value over here is 2, this would be x is equal to 2. So remember, undefined have x equal to, and 0 have y equal to. So here's a picture of all of the slopes. So we have the positive slope, where the line rises from the left to the right. We have the negative slope, where the line falls from left to right. The horizontal slope, where the line actually travels horizontally, or zero slope. And undefined slope, where the line is vertical, like said before. So suppose we look at these lines, we can see that the first one looks as if it has a positive slope. The second one has a negative slope. Since the first one goes like this, we can say it's positive. And the second one looks like it's going from left to right downwards. We can say this is negative. This one looks like it's horizontal, so we can say that it has a vertical slope. And finally, we see the vertical line, which shows that this one might be an undefined slope. So now let's look at the slope formula. So suppose we have two different points on a plane. We have x1 and y1, and similarly x2 and y2. So to find the slope for these 2 points, we would do y2 minus y1 over x2 minus x1, and this would give us the slope. And this is known as the slope formula. So suppose we have 2 points, 0, 25, and 6, 85, we would do 85 minus 25 over 6 minus 0. We get 60 over 6, which gives us 10. So the slope of this line would be 10, which basically means that it increases 10 in y every time it increases 1 in x, since it's basically just 10 over 1. Suppose we have 4, 2, and -2, -1. We do -1 minus 2, which gives us -3, over -2 minus 4, which gives us -6, and we would get -3 over -6, and these cancel out as well as these to get 1 over 2. So the slope is 1 over 2. So finally, let's look at direct variation. So direct variation is a special type of relationship that can be written in the form y is equal to kx. So in this one, we have k, which is the constant of variation. And k is multiplied times x. And y is equal to whatever k is times x. So for example, we have y is equal to 3x. Over here, 3 is the constant of variation. So finding direct variation from ordered pairs. So suppose we are given this table with a set of values which are x and y. We have 1 to 6, 3 to 18, and finally 5 to 30. So if you add 12 to 6, you get 18. You add 12 to 18, you get 30. Similarly, you add 2 to 1, you get 3. And you add 2 to 3, you get 5. So to find the slope, we will do change in y over change in x, which here is 12 over 2. And we could simplify that to 6 over 1. And the slope is 6. And we would write it y is equal to 6 into x. Since if you do 1 into 6, you get 6. 3 into 6, you get 18. And finally 5 into 6, you get 30. So we could say that the slope is 6, since y is equal to 6 times whatever x is. So if y is 6, then x has to be 1. And the constant of variation over here would be 6. So 6 is equal to the constant of variation. So now let's solve a few problems. Suppose we have the following problem. Y is equal to 4x plus 9. We would first look if we see y is equal to kx. And here we see that we cannot see y is equal to kx, as we see it's actually y is equal to kx plus 9. So since it is written in such form, we say that this function is not a direct variation. So let's look at another one. Y plus x minus 5 is equal to -5. Or y plus x minus 5 is equal to -5. So if we add 5 to both sides, we get y plus x is equal to 0. And then we can subtract x on both sides to get y is equal to -x. So at first glance, you might think there's no k, so this can't be a direct variation. However, if you look closely, we can see that it's actually y is equal to -1 into x. So we can see that the actual direct variation would be y is equal to -1x. So the constant of variation would be -1. So we conclude that the constant of variation is -1. So that's all I have for this video. I hope this video helped you with the basics of linear functions. And if this was beneficial, please do make sure to like and subscribe. And yeah, thanks for watching, and I hope I'll see you next time. Bye!